Hello, let's continue our Sudoku adventure with Count Exum the Great by GDC. So this continues our Exum theme week, although it's Exum in the title today. I like that because we're counting and we have Exums, so it's Count Exum. Anyway, continues our Exum theme week. Today is Saturday, so we have one more puzzle after this. And then the remaining ones that were created for this theme week will just be sprinkled throughout the rest of the month, as we usually do. All right, so let's go over the rules. We do have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these clues outside the grid, the 16, 18, 15. The way these clues work is they are Exum clues. So the digit next to the clue, like this one, and this one, the digit next to the clue is a count. So let's say this was a 5. That's telling us that we're using 5 cells, starting from that count, including the count, in order to sum to the clue, which is 16 here. So we need these to add to 16. I'm not going to try to give an example there. And if this was, say, a 5, then these would add to 16. If this was a 4, then these would add to 16, leaving behind these two. All right, hopefully that's clear. We also have these little brown arrows in the grid pointing in certain directions. A digit in an arrow cell, like let's say this was a 3, counts the number of digits that are strictly larger than itself in the indicated direction. So this would tell us that all 3 of these are bigger than 3. So we do maybe like 4 and 4 and 4. That would work. Or 4 and 5 and 6. Or 6 and 6 and 6. Just the count of how many are bigger. If this was a 2, then my count would be 2, and then that would be wrong. But if this was, say, a 1, that would mean only one of them is bigger than 1. And we could actually do that. We could do 1, 1, 2, 1. So only 1 is bigger than this one. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. These exums are very large. Let's start with the 18. Now, the way to think about this is when you have a very large exum clue, it's kind of like you can think about the inverse, because we know that the entire row or entire column adds to 21. Just if you add 1 through 6, that is 21. And so we need to remove enough cells from the end such that we now add to 18, which means in this case, to get from 21 to 18, right? 21 minus 18, that's going to be 3, meaning that we're leaving a sum of 3 behind. So we know for a fact that this is a 4 or a 5 because we're either if this was a 5, we'd have a 3 here and the rest would work itself out. And if this was a 4, we'd have a 1, 2 pair here, and the rest would work itself out. If this was a 3, then these 3 cells would have to add to 3 somehow, which isn't possible. So 4 or 5, and then we know that this cell here is from 1, 2, 3, because it's either, if this is a 5, this is a 3. If it's a 4, it's part of a 1, 2 pair. Now we can't mark a 1, 2 here, because if this is a 5, this can be anything at once. But the kind of union of both worlds is this penciling here. Now for 16, how much is left behind? It's 5. So again, it's 4 or 5. And then 5 is left behind, which means either this is a 5 or it's involved in a sum to 5. Now, if it's involved in a sum to 5, what's interesting is if this is the 4, we can't actually do a 1, 4 here because we'd repeat the 4. So the only way to sum to 5 would be 2, 3. So actually, this is 2, 3, or 5. And if this is a 4, this is also a 2, 3. All right, 15, we leave behind 6. Now, it's tempting to say that, oh, that means this can be a 3, because now these 3, the outies, can add to 6. But unfortunately, or fortunately, we would need to use the 3 to get to 6, because 3 cells adding to 6 would be 1, 2, 3. So it still cannot be a 3. It's still 4 or 5. If it was a 5, this would end up a 6. If it was a 4, then these two add to 6 without 4, which means 1, 5 is the only option. So that does actually mean that one of these two is a 5, so we cannot put a 5 in between them. Right? Either this is a 5, which makes it a 5, or this is a 4, which makes this a 1, 5 pair. All right. Again, we can't do 2, 4 with a 4. That would repeat the 4. All right, so I guess we have to think about these now. We actually proved in the example that this can be a 1. We can do 1, 2, 1, 1, and the count would only count this guy. That would be 1. So this is completely unlimited at the moment, unless we can't put 1, 1 here, which is something we'd have to prove. What about this guy? So this needs to be at smallest a 1, 2 pair, and this could be 1, this could be 1 at the moment, as far as I can tell. And so this is at least Let's see. This can't be a 1. Oh, no, this could be a 1, actually. If this was a 1, we could do 1, 1 with a 1, 2 pair here. The 2 is the only one strictly larger. So this isn't limited either. I hope this one's limited. This has the same thing. This could be a 1, 2 pair with a 1, 1. And this could be a 1. So is there more I need to think about in terms of interactions here? Okay, there's a little bit of an interaction here. I wonder how much we can do with that. If this is a 5, then that eliminates 5 from here, making this have to be a 4. So 5 here forces a 4 here, which would force a 2, 3 pair here. If this was a 4, though, we don't have any similar restriction. If this was a 5, oh, sorry. Yes, this is our in. I missed one case here being wrong. If this is a 5, then this has to also be a 5 in order for the outie to add to 5, and that doesn't work. So 16 can't actually be a 5, so 16 is a 4. Right, the only way to do 16 in 5 cells is 1, 2, 3, 4, 6, which excludes the 5. All right, so this is a 2, 3 pair. It does not necessarily mean this is a 5. But it does, let's see what this leaves behind. It leaves behind a 1, 5, 6. Now, I don't know, these just don't seem all that powerful right now, these diagonals. So I'll have to pay attention to the exums a bit more, I think. So if this was a 5, this ends up a 6. If this was a 4, this ends up a 1, 5 pair. So we know that these can't be 5. We knew that already. If this is a 5, this ends up a 3. If this is a 4, this ends up a 1, 2 pair. Wow. Nothing here is like screaming at me like, hey, this is what to do. I guess I could mark this as, oh, okay, so there's a maximum. These have maximums, right? This can only go up to 3 because it can only count 3 cells. This can only count up to 4. And this can only count up to 4, so maybe that's helpful. And this isn't 2 or 3. So I guess the question is, can all 4 of these be bigger than 4? Yes, we can just make them all 5 or 6. So we know 1 is possible. But we'd have to do 1 here, and a 1, 2 pair up here. Now, is there a problem with 1 and 1 like this? Makes this a 2, 3 pair. I don't immediately see a problem with that. 6 in this row is in one of these two. Can this be a 4? Yeah, we'd have 5 6s across here. This would be a 1. There must be some interaction I'm missing. I do see how these two kind of restrict each other, because this wants these to be, this affects these two and this affects these two. So like having them both be small would be difficult. Would it? I don't know. Yeah. Obviously small numbers in these are more difficult than large numbers. Or I don't know. Is that even the case? Like the 1 is very restricted. 1 would force this to be, well, not this to be anything, but it would force this to be 1, 1. A 1 here would force this to be 1, 1. So obviously that's incompatible. And a 1 here would force this to be 1, 1. So at most one of these is a 1. Well, if this was a 1, this would have to be a 1. Is 4, I mean 4 just requires 5 6 pairs across here. Okay. So I've got my 15 exum, I've got my 18 exum, and I've got these 3 arrows. That's all I've got to go on. I don't see any Sudoku off of what I've penciled. We know one of these is a 6, I guess. 2 3 pair, these are 1 4 5 6. We know this isn't a 5, so it's 1 2 3 4 6, which is really not helpful. Do both of these have to be a 1? I don't really see why. Okay, let me think about this a little bit further, because a 4 here might be interesting. Oh yeah, remember that 4, now that I have this penciled, it becomes more obvious. Remember that 4, remember the Audi is 6. That forces this to be a 1, 5. In fact, this can't be a 1, but we can go further than that. Since this can't be a 5, this would be 1, 5. But now notice how this has no value. If this is a 4, this ends up 1. So we can't use the 1 or the 4 to add to 6 and 2. And that removes all the ability to add to 6. So this can't be a 4. This is a 5, and this is a 6. Okay. So what can we do with that information? This will just work itself out as 1, 2, 3, 4. I got this 5. Okay, well, I mean, I got the digit, but I don't know if it helped. So if this was a 4, remember, these are all 5, 6 pairs. So this would have to be a 5 because of the 6 here. This would be 5, this would be 6. The 5 would make this a 4. I don't know if that's kind of quite a bit of a chain. If we recall, a 4 does put a 1, 2 pair here. So a 1 forces these two to be 1s. A 4 forces this to be a 1, 2 pair. Or, sorry, this to be a 1, 2 pair. Oh, and that doesn't work. Okay. I don't know. There might be something easier, but this is kind of the chain I'm using here. Remember, if this is a 1, then we end up with 1, 1 here. Okay, so that's one thing. If this is a 4, then we end up having to put a 5 up here, which makes this a 4, which makes this a 1, 2 pair. Okay, I can do that. I can do this much more easily. If this is a 4, this is a 1, 2 pair. And now look what happens to this cell. It has to be 3, but now we cannot have 3 digits bigger because this 1, 2 will be smaller. We'd have at most 2 digits bigger. So that doesn't work. It cannot be a 4. So it must be a 5, which forces this to be a 3. All right. So now only 1 or 2 are bigger here. Do we know that this one will be bigger? It could be 2, 1. So no, we don't. If it's a 1, obviously this is bigger. 6, 5. Okay, so I have all my Exums taken care of. This 5 placed the 6, this 5 placed the 3, this 4 placed the 2, 3 pair. Everything else will work itself out. So it's got to be the arrows now. Is there a problem with 1, 1 here? I think this 6, 5. This was 2. I don't know. Okay, now let's think about this. Oh, yeah, so now this 4 doesn't work. Because we can't have all 4 of these. This one is 1, 2, 3. Right, C's 4, 5, and 6. So this cannot be a 4 because this 1, 2, 3 can't be included in the count bigger than 4. We only have 3. So this has to be 1. And remember, the 1 does force 1, 1, and then a 1, 2 pair here. So that makes this 6 and 5. That makes this a 2. So we know this is bigger than 2 because 1 is used. And we know this is bigger than 2. So this has to be the 2 because it can't be 1. Oh, no, sorry. How do I do this then? Oh, no, sorry. The other way around. Oh, shoot. I think I might have made a mistake. Oh, it doesn't have to be 1, 2 pair. Sorry, just one of these is 1, and this can be with anything. Okay, so now that fixes it. This does have to be a 2, though, because we know this will be bigger. This is a 4, 5. In fact, this is 4, this is 5. So these 2 are bigger than the 2, meaning this has to be 1 or 2, but it can't be 1, so that's a 2. Yeah, sorry, 1, 2 was just the smallest they could be, but they didn't have to be 1. The other digit doesn't matter. Okay, this is 6, this is 4. This is a 1, 6 pair, and this is a 2, 3 pair. That 2 tells us the order. Excuse me. 5 is placed here in this box. So this is not a 6. This is 1, 6, and 1. This can be anything. So 1, that's bigger. This, in fact, is from 3, 4, 6. That's not a 6. This is known as a 2. All right, this is still a 3, 4, but the 2 isn't bigger than a 3 or a 4. So the best we can do is 3. So this is a 3. That's 4, that's 2, that's 3. And this just has to be bigger than 3, so it can't be a 3. So it's from 4 or 6. Oh, it's only 6 then. Can't be 4 or 5, so it's only 6. That's 3, 4, and 6. These two digits are a 3, 4. We know the order. And we need 1, 2, and 5. The 1 goes here, the 2 goes here, the 5 goes here. Very nice. Cool puzzle, GDC. It took me a while to like come back around to realize some of the Exum options weren't possible. This one was really interesting, how the 4 made a 1, 2 pair, which then forced this to be a 3, but then the 1, 2 made that impossible. So it was really interesting how these Exums ended up that way. And thinking about the outies was pretty much necessary for this solve, I think. I think it would have been much more difficult if you tried to think about them directly. So very good technique to know how to use. All right, well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.